Some of the more advanced features in SolidWorks can be a bit intimidating, but don't worry, that's what I'm going to be covering in this video. I'll go over fillet, revolve, and sweep features again step by step, and I'll also be touching on 3D sketches which allow you to sketch in a 3D space rather than on a 2D plane, and curves, including how to create a helical curve and how to use composite curves, which are super useful for doing more advanced sweeps. Alright, so the first thing I wanted to do is show a better example of how a revolve can be used to make cylindrical parts. So let's go ahead and start a new part, and I'm going to start a sketch on the front plane, and then I'm going to start sketching kind of a square rectangle type feature here, and then I'll start constraining and dimensioning this. And what I'm going to do is I'm going to lock those two center points down here. I'm going to make this vertical, clicking that line, selecting vertical on both of those. I'm going to make these two legs equal, like that, and then I'm going to start dimensioning. So let's go ahead and make this 1 inch, and we'll make this 3 inches, make this 0.5, this 0.5, make this 0.25, this 0.25, and what are we missing here? I'm going to make these collinear. What else are we missing? And these also need to be collinear. And then I need to kind of give this ID something. So what I'm going to do is create a center line, and this center line is actually going to be my revolve point. And this is a common way to use the revolve feature. And once I get this revolve made, I'll kind of go back through and show why this is so powerful. So when I start the revolve feature, it's asking for the axis of rotation. So I'll go ahead and click that. Now we have this cylindrical kind of part here. So revolve is really useful when you're creating any kind of cylindrical profile. I could have created this with a bunch of extrudes. You know, I could have extruded this flange and then, you know, this one here, and then come in there and made that one as well, and then did this one last, but that would have been 4 features. So this is a much more efficient design flow to use a revolve feature for really any kind of cylindrical part. All right, so now let's talk about sweeps. So sweeps are a really common feature that you'll use when you're working on any kind of piping or tubing, and a really great tool that SolidWorks has that's going to help you with that. If you're designing a 3D pipe or tube, you're going to want to use a 3D sketch. To show you how this works, let's start a line, and you'll notice right away that on my cursor there's a little bit different heads-up display. So it's showing X, Y, and that means that I'm currently sketching on the XY plane. So if I look down here at my origin indicator here that's showing the different axes, I can see that the Y direction is currently up and the X axis is out this direction. So that's telling me that I'm sketching on the XY plane. So if I start a sketch on the origin, you can see that my line is kind of on that plane like this, right? So if I create a line up like this, and now I want to come out on the Z axis, I can actually change that by hitting the tab key, and now I'm on the YZ axis. Another way that I can change that, if I go back to the XY axis, is I can actually rotate my camera view like that, and it will switch the plane that I'm sketching on accordingly, so that you're always kind of sketching along the plane that you're looking at. I generally tend to leave things kind of in an isometric view like this, and then use the tab key to switch between my views. So I'm going to go out this direction, then I'm going to hit tab, come back toward us, and then go down, and then back toward us again. Then I'm actually going to go all the way underneath, kind of pass through like that, then go back out this direction, back toward us, and then hit tab to come back up. And what I'm going for is to kind of create like a knot design here, so something like that. And let's start snapping dimensions. And once you get your 3D sketch kind of generally sketched, as long as you're working with lines, it's pretty straightforward to dimension. So first, let's dimension this first line segment, and I'm going to go 3 inches, and that will scale the rest of the lines appropriately. And then I'm going to add a dimension here, go another 3 inches, we'll add another 3-inch dimension here, go 3 inches down, and then I'm going to go 6 inches, and then 4.5 inches back, and then 4.5 inches here, and 6 inches there, and then let's go 6 inches up. All right, so now that's kind of my rough 3D sketch. So you can imagine if I were to create a profile down here, that would follow this and kind of create a knot pattern. Before I create the sweep, I'm going to create a sketch fillet. We're going to do a 1-inch diameter. I'm just going to grab everything. That will add radiuses to all of those corners. Click OK there, complete that fillet, and now we can complete this 3D sketch. So let's create a center rectangle on the top plane. And we're actually going to create 2 of them. We're going to make these collinear, and then I'm going to dimension this at 1 inch, and this at 0.125. So let's say this is 1/8 inch tubing. and then I'm going to make these two equal. That should define my tube. And just for the sake of it, let's go ahead and create some fillets in here, make it a little bit more true to life with how square tubing would be. So this is just letting me know that it's going to delete some relationships in order to create this fillet. So I can just go ahead and click OK through those. All right, so now I have my fillet, click OK there, and that's my tube profile. Let's go ahead and finish that. Sketch. Now I can select both of these sketches and create that sweep like that. All right, so let's go through another quick sweep example. And what I'm going to do here is I'll show you guys how to create a helix and how to make kind of like a spring. So if I start a new sketch and I create a circle, this will define the diameter of my spring. Say it'll be a 3-inch spring. If I complete the sketch, go back to features, and then under curves, if you're working with a lot of sweeps, it's going to be worth knowing how to do this, and I'll come back and show another example of how to create a composite curve and how that helps you create sweeps. But for now, let's look at this helix and spiral feature. So you can see when I start that, it starts this helix, and a couple different ways that I can define this. I can define it by pitch and revolution. So pitch is the distance between each revolution as it comes back to the same point. So right now there's a 3-inch pitch. So if I make that exactly 3 inches, there's 3 inches from this point to that point. Let's go ahead and decrease the pitch here and then add, say, 10 revolutions like that. And let's actually make it 20 right away. Click OK there. And now I have this helical spiral. So now if I create a new sketch, let's go to the front plane because that's going to intersect this point here. Just for the sake of it, let's make this a hexagon. And I'm going to define the width of that hexagon to be 0.375. Actually, that'll be too big. Let's go 0.1875. And then I'm going to select my helix and then this point, and I'm going to say pierce. Now that pierces it so that it's actually coincident to the helix. That means I cannot move that now. So the center point of my hexagon is pierced onto this helical profile. So pierce brings something that is on one plane tangent to something that was created on a different plane or out in 3D space. So pierce is also another type of constraint that you'll need to understand when working with sweeps. So let's just quick define this, and I'll make that horizontal to define my hexagon, complete that sketch, select both the helix and my profile, and start a sweep like that. Hit complete there, and now I have this kind of spring pattern with a hexagon profile. And there we have it. So just to go through the rest of the parameters within a helix, I can reverse the direction of the helix like this by checking that. I can also change the direction of the actual helix. So by changing that to counterclockwise or clockwise, I can change that. I can make this a tapered helix by giving it an angle like that or flipping the direction. I can also make this a variable pitch by selecting the variable pitch, and then it gives me this table here where I can input different pitches at different points along this helix. So let's say the first 10 revolutions I want to do at a 1/4 inch pitch, but then the next 20 revolutions I want to do at a 1-inch pitch. I can do that like this. So it's actually, the way this works is it's actually asking for the first 10 revolutions are at this, and then the next 10 are at a 1-inch pitch. So if I enter 10 here, it's saying that the value must be greater than 10 because it's actually from the very first point. Each revolution in the table is from the very first point. I could also define a diameter like this, and I can get some pretty interesting helixes. So let's go back to constant pitch, and then let's look at the way that we can define the spring. So right now we're on pitch and revolution. I can do a height and revolution, so I can define 5 inches, the number of revolutions. And also I forgot to mention the start angle. So the start angle is at 270 degrees. That's basically defining this point right here at what angle from the origin is that starting at. So I could start that at 90 degrees, for example, and that moved it 180 degrees to this side. If I wanted that to start on, a different plane, for example, I could start that right there so that I can sketch on the YZ plane to start my profile. I can also define the height and pitch, or if I switch this to spiral, I can actually create a spiral pattern. So it's a flat 2D. And then with that, you're defining the pitch, number of revolutions, and your start angle. So just something to be aware of with sweeps is if I create, let's say, one sketch that's, something like this. create a tangency out this direction like that. Let's just say at like a 120-degree angle. Create my radius at 1 inch. And then from this point to that point, we'll say is 3.5 inches. That point to that point, going to be 3 inches. So I have a sketch here, and let's just say I run into a scenario where I have two sketches that are kind of merging here at the same intersection. So if I have another sketch like this, let's make this at another 120-degree angle and define this at 1 inch radius. Then from there to there is 3 inches, and from here to here is 3.5 inches. So I kind of have two sketches that really, they intersect, right? But sweeps don't recognize that these two sketches are going to intersect by default. So we might have to do something a little bit different and use this composite curve feature to combine these into one curve. So by using that feature, I can select both of those sketches to combine them into one composite curve. And now this will allow me to take advantage of one consistent curve when doing a sweep. So another thing with the sweep feature is if you're just doing a circular profile inside of the sweep feature, you can just select circular profile. So all I have to do is select my path, which is our composite curve, and then select the circular profile and pick my diameter, click OK there, and now I have this swept part. All right, so let's take a little bit deeper dive into fillet features. And before we talk more about fillets, I didn't point out the chamfer feature last time, which works very much like the fillet feature or the chamfer feature that we saw in sketches. So if I want to create a simple chamfer, I can just select an edge just like that, or I can select a face to grab all the edges of that face. There's also some different chamfer types that we can define here. So by default, it's set up to be a distance and angle. So I can change my angle here, of course, or my dimension to 1 inch like that. Or if I use a distance chamfer, by default it's symmetric, but if I want an asymmetric circle and I want to define that by using 2 dimensions, I can do that just like this. So that will create a chamfer like that. I close this and then reopen a chamfer. I can also select a corner to chamfer like that. I would think that this should allow you to select multiple edges, or multiple vertices, but it doesn't look like you're able to. So it only allows you to do one at a time, which is kind of inconvenient. Of course, you can make this equal distance or define those 3 dimensions of that corner chamfer as well. Let's close that and start a new chamfer again. If I wanted to define the straight line distance of the chamfer, I can select this type of chamfer. Sorry, actually I would select the first face and the second face of that chamfer. And this gives me the opportunity to select chord width or hold line, which I'm not familiar with what that is. I'll have to look into that more, but chord width will allow you to input the straight line distance of that chamfer. So if I create that chamfer like that, and then I use the measuring tool to actually measure that, it's actually 1 inch as a straight line distance. Let's go ahead and delete that and start another chamfer. And then the last chamfer type allows you to create an edge offset. So if I select an edge, and we'll just leave it as a simple 1/2 inch symmetrical chamfer, this type of chamfer allows you to create an offset from an edge. So once I check this box, it displays these 2 points, this green and purple kind of handle that you can click and drag like this to move that chamfer away from the edges. And I can define those 2 points as distances from the endpoints of the chamfer, like this. Or I can do that as a percentage offset, or I can say 33% to split that by thirds. Or you can use a reference offset, which will allow you to pick another point. Say I had a feature down here that I wanted to align that offset to. I could click that in order to set my offset aligned with some other feature. Okay, so now let's take a deeper dive into fillets again. So if I start a fillet command, last time I just showed a basic filleting example where I came in and select some edges and applied a basic fillet. Of course, I showed that you can adjust the radius, and then just like the chamfer feature, you can make that asymmetric where you can apply 2 different radius fillets like this, where that is kind of an asymmetric fillet where it's 1 inch on this leg and about 0.4 inches on the vertical leg of that fillet. When I select an asymmetric fillet, it also allows you to select different types of profiles. So I can do an elliptical, which is the base style of asymmetric fillet. I can also make that conic, where it allows you to put in a row value. So if I made this 0.75, it gives it a sharper fillet on that edge. You can also flip the direction using this. So I'll jump back to the symmetric fillet. So you also get some different profile options with the symmetric fillet. So the conic type profile with the row value that I can enter there. I can also make a conic profile where instead of a row value, it gives a inner radius dimension. So if I make this outside radius, or the larger radius, 0.5, it'll be 0.5 from dimension to dimension, but then this inner radius is actually at 0.25, so it's kind of a compound radius. And then there's also this curvature continuous, which I'm not entirely sure how it's calculated, but it is slightly different than a circular radius, as you can see there. As I change this back and forth, it's a little bit sharper on that inside. So then, just like I showed with the chamfer, I can offset the fillet from either edge. Then down here, there's some other ways to control the filleting. So select through faces, which allow me to kind of select behind there like that. If I turn that off, I cannot select that edge that's shown behind a face. So those are your basic controls for filleting. Then across the top, there are also some other types of fillets. So I can also create a variable size fillet, and what this allows me to do is make the radius different along the edge. So you can see that it adds this table here, which allows me to set different radiuses at different points along that edge. So for starters, let's bump this up to 5 points. So that'll give me 5 points at which I can control the radius. I can select a start point and enter a radius there. And I can select the other endpoint and put in a radius there. And then what I can do is I can click on each of these points and set a different radius at each one of those points. So if I go 0.25, now it's a 0.25 radius at that point. If I click on the second one, I can set a radius there. I could make that 1 inch. Then here I could go back down to 0.25. Then here, let's say I go back up to 1 inch like that. At my last point, let's just say we go back to 0.25. So I can get kind of a crazy radius pattern by creating those different radiuses at different points along the edge. So by default, it's smooth transition. I can set that to a straight transition, which in this case doesn't seem to be doing much. If I complete that, let's see what it looks like. So pretty interesting fillets that you can create with a variable radius fillet. So let's start a new fillet command and see what else we have. So then there's the face fillet, which I'm not quite sure what the advantage is, but basically it works where you select one face and then another intersecting face. It will create fillets automatically like that. And I could select other intersecting faces as well to create fillets wherever those two faces intersect. There's probably an application for this that I'm not aware of where this comes in handy, but I'm going to hit cancel and then start another fillet command. And the last type of fillet is a full round fillet, where it allows you to select 3 faces like this, where the middle face selection is intersecting 2 other planes, and it will create a full round on that intersecting face like this. So I can create that, and that creates a full round fillet. Then the last thing I'm going to show is the fillet expert. So I'm going to quick suppress this, and then I'm going to start a new fillet, and I'm going to go to the fillet expert tab up here. And what this is it's a way of creating multiple fillets without leaving the fillet command. So if I was creating a bunch of different fillet features and I wanted to do that maybe a little bit more quickly, I could do that through this fillet expert. So to show you how this works, I can start selecting edges, so it's very much the same as the fillet command, but let's say I want these to be 0.5, I can hit apply. That creates a fillet feature, so that's this fillet here, but you'll notice that it doesn't leave the fillet expert. So then I can continue to go around and select other faces, and let's say I want those at a different radius. I can select some of these other faces, click apply, now that's a different fillet feature. And I can come in here, go to a 1 inch radius, select this internal edge, click apply. At any point I can also go to the change tab, and let's say I wanted to change some of these, where now instead of 0.25 here, I can resize that to 0.5, click resize, and now that's a 0.5 inch fillet. The other thing inside the fillet feature that can be useful is that I can select an intersection of 3 fillets like this. I can click show alternatives to change how that fillet will intersect. So it gives me a preview of the different ways that I can make that fillet intersect at a 3-point intersection or a 3-edge intersection like this. So a couple of other things to point out with the fillet feature. Let me just go ahead and grab all of my edges here. I'll use this internal to feature, select all my edges, and let's say I wanted only one feature to define all the radiuses on this part, but I want different radiuses for each edge. So if I check this multiple radius fillet, it actually gives me the ability to define the radius for each edge individually. So let's just say I want all of my bottom edges to be 1 inch. I can do that, and I can come around, select all of my bottom edges. Right here is the last one. And now all 4 of my bottom edges are 1 inch radiuses, while everything else is a 1/2 inch radius. And then one more thing to point out with fillets, there is this setback parameter, which allows you to define a basically a blend of 3 intersections. So if I have 3 fillets intersecting in a corner like this, I can make a little bit softer corner at that intersection. So I'll show you how this works here by selecting an intersection like that, and then it is looking for an input of how far is the setback for each direction that you'd like to start blending those lines. So there the preview goes, and you can see there's kind of like this radius starting here and also this way along that edge that starts to soften that corner. So now if I want to change how far I want to blend this or how far that setback is, I can come in here and I can enter 1 inch, but it only updated one of those 3 points. So I can hit set all, and that will set all 3 directions of that intersection to 1 inch now. So I'm going to complete this. So again, just to kind of clarify here, the setback parameter is the distance from this point where it starts to blend that corner to the start of the fillet. So the straight line distance between this point and that line is 1 inch. I should be able to even measure that like this. Yep, so 1 inch there. Alright, thank you for watching. If you liked this video, be sure to leave a like and subscribe if you want to see more future videos on SolidWorks and other engineering topics. In future videos, I'll be covering more SolidWorks features, sheet metal drawings, assemblies, and plan to be going through some cool examples so you won't want to miss it. Thanks for watching. We'll see you in the next one.